Okay, so we're now going to look at arithmetic in polar form, and we're actually only going to be looking at multiplying and dividing. While it's technically you're able to do adding and subtracting in polar form, it's actually so tedious, and I don't want to say complicated, it's so tedious that it's just not even worth discussing. It's actually going to be quicker to convert them to rectangular form and then do the adding. And I'll write that down when we get to that here. So we're first going to talk about multiplying in polar form. And that's actually going to be very straightforward. So we're going to have two complex numbers in polar form, and we want to multiply them. Now, doing this on calculators, it really depends on the model of calculator. My calculator that I have at home it's not easy to actually multiply in polar form on my calculator. It's actually easier just to do it by hand, as opposed to trying to type this expression in. And when I say by hand, you'll see what I mean in a second. So it turns out that if we were to do this, we have ZM1 at an angle of theta 1 times ZM2 at an angle of theta 2, and this just gets me ZM1, ZM2 at an angle of theta 1 plus theta 2. So we multiply the magnitudes and add the angles. And that's what I mean. I don't actually try and write these. When I say I don't try and write this expression in, I don't try and type this into my calculator. I don't try and type that in. I essentially just say, oh, well, wait a minute, what do? I just multiply the magnitudes, so I'll do that on my calculator, and then add the angles, and if I need to, I'll do that on my calculator. So let's look at an example here. So Z1 is 10 at an angle of 25 degrees, and Z2 is 20 at an angle of 30 degrees. And so Z1 times Z2 would just be 10 times 20 at an angle of 25 degrees plus 30 degrees. Then we just do that and we're done. 10 times 20, 200, 25 plus 30, 55 degrees. And division, quite frankly, is just as easy in polar. You might even be able to guess what you would do in division. So if we had Z1 divided by Z2, this is actually going to just be Z1 magnitude divided by Z2 magnitude at an angle of theta 1 minus theta 2. And so if we do a similar kind of example where we have Z1 is equal to, let's say, 50 at an angle of 45 degrees, and Z2 is 10 at an angle of 60 degrees, then Z1 divided by Z2 would just be 50 divided by 10 at an angle of 45 degrees minus 60 degrees. 50 divided by 10, of course, is just 5 at an angle of minus 15 degrees. And we're done. So multiplying and dividing in polar form is really easy to do. Adding and subtracting in polar form is not so easy to do. Honestly, if you were to add and subtract in polar form, what I prefer to do instead what I first do is I actually convert to rectangular. Then add write final answer in correct format. So let's look at an example of that, what I'm referring to here. So let's look at, for instance, if we have 4 at an angle of 5 degrees minus 2 at an angle of 15 degrees. Well, what I first do is I convert both of these numbers to rectangular. That's what I do. And so let's go ahead and do that to the side here. So 4 at an angle of 5 degrees, that would get me A is equal to 4 cosine 5 degrees. B is equal to 4 sine of 5 degrees. So let's go ahead and do that real quickly here. So 0.349 for this one. And 3.985 here. And then we'll convert the other one. 2 at an angle of 15 degrees. A would be 2 cosine 15 degrees. B would be 2 sine 15 degrees. And if your calculator has a button to convert quickly, you could enter it in here. Or actually, your calculator maybe makes it easy to enter these numbers in. Maybe you can just enter this directly in your calculator. My calculator is actually not easy to enter this directly in, so I convert it to this. So 15 cosine times 2, so 1.932. Sine times 2.518. And then I would say, okay, well then this problem now is this. It is 3.985 plus j 0.349 minus 1.932 plus j 0.518. And then doing that arithmetic, what was it, 932? I get 2.053 minus j 0.169. And now if the answer didn't care what form, if it said in rectangular form, I mean, I'd be done. If it wanted polar, I would convert this to polar. So let's go ahead and convert it to polar as well. Technically it's a negative in there, but it's going to just become positive. So 2.06. And then this is in, if you were to plot this, this is in quadrant 4. So theta is just equal to the inverse tangent of negative 0.169 divided by 2.053, and so that would be negative 4.71 degrees. So then, in polar form, the answer would be 2.06 at an angle of negative 4.71 degrees. Now again, I would definitely be turning to my calculator to do these problems. The only ones I want you to do by hand and show all your work is the problems where you're asked to convert. And I'll show you here in a second what I mean by that at the end of this video, or maybe I'll make a brief video going over some of the homework problems. Okay, one final thing we should talk about before we finish here with polar format. There is another way to write polar format. So we're used to having my complex number being z sub m at an angle of theta degrees. Another format is z equals z sub m e to the j theta. So this is still polar format. So maybe I should say, instead of another format, another way to write it. But this is still polar format. It's just a different way of writing it than with an angle. And sometimes this makes it actually easier to enter it into a calculator because calculators know how to handle this. Now, to finish this up or wrap this discussion up here, this really, and we will use this occasionally, where this comes from or why we can write it like this, and this is polar format, is there's a very important equation that's called Euler's equation. And what it says here is that if you have e to the j theta, that is the same thing as cosine theta plus j sine theta. And I'm not going to go through the math on why this is. This has to do with complex numbers, complex analysis. It's well beyond the scope of this course. But if we have here z equals z sub m e to the j theta, what that is saying is this is the same thing as saying z sub m cosine of theta plus j z sub m sine of theta. And what I want to point out here, this is polar format, and this is rectangular format. Because look, you got, this is actually here. If we look here, this right here is finding the A, and this right here is finding B. So it's just an identity or an equation that's used to illustrate the relationship between the polar and rectangular format. Now, the reason I point this out is that the textbook will sometimes use this notation for complex numbers. It will also use this notation as well. So you just want to make sure that you can recognize that, hey, these are really saying the exact same thing.